So these two questions are looking really at inverses, and the key thing here is knowing the ranges for inverses. So I'm just going to have a look at our chart here. You can see that the range of values for inverse sine and inverse tan are really quite similar, except for the rounded brackets here, it's not inclusive, and for inverse cosine it's between 0 and pi. So if we have a look, our question is for inverse sine. So we know first of all that our range for inverse sine is between negative pi on 2 and pi on 2. So that's just going to help us to work with this. So the first question, question A, evaluate each of the following. You're basically trying to find an unknown x, and you're looking at the inverse sine of 1. Now what you can do is you can actually take this sine over to this side of the equation. So this becomes sine of x equals 1. And the question now is, what x's would give you this sine being 1? That x could be any, well, there are lots of options because you can always keep going around the unit circle, but we have to stay in this particular range of values. So we know for x equal to 1, and that's going to be just straight up here, there's going to be pi on 2, and then that's it, because 3 pi on 2 is not in this range of values, and neither is negative 3 pi on 2. So that's our only option here, so that's our answer. So it's a nice easy one. The second one, inverse sine of negative root 2 on 2. Now, as soon as you see the root 2 on 2, you'd be thinking something to do with pi on 4. But again, I'm going to take the sine over to the other side. And so now I've got negative root 2 on 2 equals sine of x. What x would that be? Now think about where negative root 2 on 2 has to be. It has to be down in these quadrants here, here and here. But remember that we're looking at negative pi on 2 to pi on 2. So that means we're actually only interested in this side. So that means that we have to be we have to be this answer here. It's the only one that will work. So that would be, remember this is pi on 4 from our triangle. So this x here that would satisfy would have to be not just pi on 4 but negative pi on 4 to get us back to this point here. So that's our answer. So that's looking and using inverse sine. This next one is a really similar example. So this time you're looking at cosec. So again, we're looking at solving an equation with trig. So cosec, I'm just going to write out what cosec is. Remember the third letter there is an s. So that's going to be sine of 2x plus 1 equals 2. Take the 1 over to the other side. So we've got 1. And now because this is a fraction and you'd really rather have the sine x up the top, we're going to flip. Now there's actually nothing, well there's a 1 underneath this 1. So if we flip over, in fact nothing very exciting happens. So we're saying sine of 2x equals 1. So that means that 2x could be any of the values that give us a sine of 1. So we know that pi on 2 is an option. Remember though that you're going to divide through by 2 here. So you might actually be able to have another round of the circle. So pi on 2, the next one would be pi on 2 plus 4 pi on 2, so plus 2 pi, and that would be 5 pi on 2. The next one would be 9 pi on 2. So I'll put that there, we'll see what happens. So now we've got x equals, let's divide everything on this side by 2, so that becomes a 4, that becomes a 4, and you can see that 9 pi on 4 is a little bit bigger than what 2 pi is. 2 pi would be 8 pi on 4, and that's where our our end point of the domain is. So this is too big, so we've actually only got 2 solutions here. So for this particular example, still effectively doing inverse sine, you end up with 2 values for x, which is pi on 4 and 5 pi on 4.